So here we have the function x cubed times sine of x. So we have to find the derivative of this given function with respect to x. So let us treat x cubed as the first function and sine of x as the second function, so that we can apply the product rule. So we'll have the first function, which is x cubed, times the derivative of the second function, which is sine of x, plus the second function sine of x multiplied to the derivative of the first function, which is x cubed. So that will be equals to x cubed times cosine of x plus sine of x times derivative of x cubed will be 3x x raised to the power of 3 minus 1. So we have x cubed cosine of x plus sine of x multiplied to 3x, 3 minus 1 will be 2. So this is the derivative of the given function. Let's do another one. So here we have the function x cubed times the e raised to the power of x. So we need to determine its derivative with respect to x. So we have x cubed, let's treat it as the first function, and multiply it to the derivative of the second function, which is e raised to the power of x, plus the exponential function times the derivative of the first function. So we have x cubed, derivative of the exponential function is the function itself, plus e raised to the power of x times x cubed will give us 3x squared. So we can take e raised to the power of x as the common factor. That gives us x cubed plus 3x squared. We can even go ahead and further take x squared as the common factor. So we have x squared e raised to the power of x multiplied to x plus 3. So this is the derivative of the given function. Let's do another one. So here we have the function x raised to the power of n times tangent of x. So we have to find the derivative of this given function with respect to x. So we begin by treating x raised to the power of n as the first function. So we have the first function multiplied to the derivative of the second function, which is tangent of x, plus the second function tangent of x multiplied to the derivative of the first function x raised to the power of n. So that will give us x raised to the power of n. So the derivative of the tangent function is secant squared x plus tangent of x, and we have the derivative of x raised to the power of n, which will be n times x raised to the power of n minus 1. So we can write it in a simplified form. So we have x raised to the power of n times secant squared x plus n times x raised to the power of n minus 1 times tangent of x. So this is the derivative of the given function. Let's do another one. So here we have the function x raised to the power of n multiplied to the logarithm of x with base of a. So we have to find its derivative with respect to x. So that will be equals to, so let us consider log of x with the base of a as the first function multiplied to the derivative of the second function, which is x raised to the power of n, plus x raised to the power of n times the derivative of log of x with the base of a. So that will be equals to log of x base a, derivative of x raised to the power of n will be n times x raised to the power of n minus 1 plus x raised to the power of n. Now we know that the derivative of log of x is equals to 1 over x, and that's only true when this is the natural log. That means the base is e, but in our case we have the base of a, so that means we'll need to change it to the natural log. So we'll have log of x the base of a, so that's equals to natural log of x divided by natural log of a. So that means we'll have now the derivative of the natural log of x divided by natural log of a. So we get n times x raised to the power of n minus 1 times log of x to the base of a plus x raised to the power of n. Now we have 1 over log of a, so that is a constant, so that can be taken out of the derivative. So we have x raised to the power of n divided by the natural log of a times the natural log of times the derivative of the natural log of x. So final answer will be n times x raised to the power of n minus 1 times log of x to the base of a plus x raised to the power of n divided by natural log of a times and the natural log of x, so is going to be 1 over x. So we can combine the exponents of x raised to the power of n, the numerator and the denominator, so that is going to give us n minus 1, and we can remove the denominator part. Now what we can do, we can take x raised to the power of n as the common factor from both the two terms. So the final answer will be n times log of x to the base of a plus 1 over natural log of a. Let's do another one. So here we have the function x cubed plus x squared plus 1 multiplied to sine of x. So we have to find the derivative with respect to x. So we begin by treating the algebraic polynomial or the cubic polynomial as the first function. So we have x cubed plus x squared plus 1 multiplied to the derivative of the trigonometric function sine of x plus sine of x multiplied to the derivative of the cubic polynomial x cubed plus x squared plus 1, which will be equals to x cubed plus x squared plus 1 multiplied to derivative of the sine function is cosine of x plus sine of x multiplied to the derivative of x cubed plus derivative of x squared plus the derivative of the constant function 1. So we get x cubed plus x squared plus 1 multiplied to cosine of x plus sine of x multiplied to, so the derivative of x cubed will be 3x squared plus derivative of x squared is going to be twice of x, and derivative of 1 is 0. So this is going to be the derivative of the given function. Let's go to the next question. So here we have the product of cosine of x and sine of x. So we need to find its derivative with respect to x. So we treat cosine of x as our first function. So that will be multiplied to the derivative of sine of x plus cosine of x, which will be, we have already considered cosine of x, so we'll consider sine of x, the second function, multiplied to the derivative of cosine of x, which will be equals to cosine of x times, so the derivative of the sine function is cosine of x plus sine of x multiplied to the derivative of the cosine function is negative sine x. So that gives us cosine squared x minus sine squared x. Now cosine squared x minus sine squared x is also an identity, and it's an expansion of cosine of 2 of x. So the derivative of cosine of x times sine of x is cosine of 2 of x. Let's move on to the next question. So here we have the function x raised to the power of 5 multiplied to the exponential function, which is added to x raised to the power of 6 times log of x. So we have to find the derivative. So what we can do is first we can split and apply the derivative to each of the terms. So we have the derivative of x raised to the power of 5 times e raised to the power of x plus the derivative of x raised to the power of 6 times log of x. So this is the natural log, which will be equals to, so now we have in the first term, or the first derivative, we have the product of the two functions. So we begin by considering x raised to the power of 5 as the first function. So we have x raised to the power of 5 times the derivative of the exponential function plus the exponential function times the derivative of x raised to the power of 5 plus, now we consider x raised to the power of 6 as the first function for the second derivative times the derivative of the logarithmic function plus the logarithmic function multiplied to the derivative of x raised to the power of 6. So that will be equals to x raised to the power of 5 times, so the derivative of the exponential function gives us the function itself, plus e raised to the power of x times, so the derivative of x raised to the power of 5 will be 5 times x raised to the power of 5 minus 1 plus x raised to the power of 6 times natural log of the derivative of the natural log of x is 1 over x plus log of x multiplied to 6x raised to the power of 6 minus 1. So we have x raised to the power of 5 plus 5x raised to the power of 4. Since we have e raised to the power of x, the exponential function, as the common term, as the common factor in both the two terms, so we have factored it out. Plus x raised to the power of 6 divided by x will be x raised to the power of 5 plus 6x raised to the power of 5 times log of x. So this is the derivative of a given function. So here we have 1 plus x squared multiplied to cosine of x. So we treat 1 plus x squared as the first function. So we have 1 plus x squared multiplied to the derivative of the second function, which is cosine of x in our case, plus the second function times the derivative of the first function, which is 1 plus x squared. So that will be equals to 1 plus x squared multiplied to, because the derivative of the cosine function is negative sine x plus cosine of x multiplied to the derivative of 1 plus derivative of x squared. So we have applied the derivative to each term, which will give us negative sine of x multiplied to 1 plus x squared plus cosine of x times 0 plus, so the derivative of x squared is going to be twice of x. So we write a positive term as the first term. So we have twice of x cosine of x minus 1 plus x squared multiplied to sine of x. So this is the derivative of the given function. Let's move on to the next question. So here we have the function sine squared x. Now sine squared x can be also written as sine of x whole squared, which is simply the product of sine of x with itself. So now we can apply the product rule since we have two functions, sine of x and sine of x. So we have the derivative with respect to x of sine squared x equals to sine of x times the derivative of sine of x. So considering that this is the first function and this is the second function, plus now we take the second function with the sine of x multiplied to the derivative of the first one, which is sine of x. Now both the two are the same thing. So what we can do, we can write it as 2 times sine of x times the derivative of sine of x, which will be equals to 2 times sine of x times derivative of the sine function is cosine of x. 2 times sine of x times cosine of x is an identity, which is the expansion of sine 2x. So the derivative of the sine square x function is sine 2x. Let's move on to the next part. So here we need to determine the derivative of the function log of x to the base of x squared. Now we need the base to be the exponent e, so that means we'll have to change this log. So we're going to apply the property that log of a to the base of b is equals to natural log of a divided by natural log of b. So our given logarithm will now become natural log of x divided by natural log of x squared. Now there's another property of log, which is log of a raised to the power of b is equals to b log of a. Now if we apply this property to the denominator, so we have natural log of x divided by 2 times the natural log of x. Now log of x is common to both the numerator and the denominator, so they cancel out, leaving us with half. So we say that the log of x with the base x squared is actually equals to half. So the derivative of log of x with base x squared is actually equals to, or is the same as the derivative of half. Now half being a number which is a constant, so the value will be simply equals to 0.